And
The broadcast is now starting. All attendees are in listen-only mode.
all right, hello everybody. We have a good group here. This is Krishna Vidula here, and it is my distinct pleasure to introduce to you guys the speaker for today, Professor Serene Tekinay from Sabancı University in Turkey. She was previously served as a rector there and a vice rector as well, and the Dean of Engineering. She's also currently the president-elect, right, for the GEDC chair. So it's a really delightful occasion to have her. She's been very enthusiastic about anticipating this, and she's drinking masala chai for the last day or so to get her throat all organized. She was in the United States, as you can see from some of the description I've given her. She was in New Jersey Institute of Technology, U.S. National Science Foundation as a program director. She's served in senior positions in various industries, telecom and Bell Labs, and she holds numerous patents and numerous publications. Interests are engineering education, complexity, network science, mobile networks, sensor networks and applications. She founded the first digital local fabrication laboratory in Turkey called FabLab Istanbul. And she's one of the pioneers of the 5-dimensional STEAM approach to educational research, that is science, technology, engineering, arts, and math. In addition to new multidisciplinary lines of study, innovation, entrepreneurship, and the maker movement through FabLabs. And she's a consultant expert review for European Commission on Science and Technology, and sits on the elected member of the board of directors, European Society of Engineering Education. Also appointed member of several boards in Turkey, and she's now the new chair of the elected chair of the Global Engineering Deans Council. Pleasure to have a distinguished professional like Serene join us. So I'm going to give the screen to her so that she can click show my screen, and we will be off to the races here. Okay, Serene, just click show my screen.
Thank you so much, Krishna, and thank you everybody for tuning in. It's such a pleasure and honor to be addressing you today, and hopefully it will be an interactive one so that we can all enjoy. Okay, I shared my screen with everybody, I hope.
You can see it. You can, so you can move on to the next slide with the arrow to the left. There you go.
Okay, wonderful. So before I start, I just want to give you a little bit of the motivation in preparing this webinar for you. We all know as the engineering community, global community, that the engineering professional identity and engineering education is in a crisis to catch up with the requirements of the field, because the field has been ever changing with challenges that are evolving faster than education system in general, and of course that includes engineering education. So the first decade of the millennium seems to have been dedicated mostly to redefining, repositioning the field, and of course the education system, and also reposing some of the questions that have been traditionally asked. So here's an attempt to ask some of the more to-the-point questions, more urgent questions. And by no means am I going to, at the risk of disappointing you, am I here to give you a comprehensive list of prescriptions to cure our problems. As Krishna said, I have recently been humbled and honored to be elected as the chair of the Global Engineering Deans Council. And I'm looking to be a mere coordinator of efforts so that the sum of the parts will be bigger, the whole will be bigger than the sum of the parts, so we can all collectively move faster forward along the lines that we all, I know, care about. So we'll first talk about what it is that the engineering field is evolving towards. What problems do engineers need to solve? What must engineers do? Because typically younger people that we're trying to attract into engineering or get interested, excited about engineering will ask, what do engineers do? Like, what do doctors do? What do plumbers do? What do firemen do? I always answer them with the engineers should do this. Engineers must do that. And also, we have this traditional, and being a hardcore electrical engineer myself, I've been guilty for this, formulation of who should be an engineer. Oh, if you're good in math, you should be an engineer. If you're good in physics, you should be an engineer. If you're a quantitative person, you should be an engineer. Let us put all of those aside and focus on who the engineer should be, because the field is getting redefined. And of course, following this discussion, we have to take a fresh look at what engineering schools should teach. And some of the effort, I'm proud to say, is coming in from international networks of collaboration, such as the Global Engineering Deans Council that I've been privileged to be serving since, for a while, 2012 or so. And of course, we have other regional and national networks of collaboration of engineering leaders, such as the European Society for Engineering Education, the Turkish Engineering Deans Council, the African Deans Council, and so on and so forth. And since this is a IFES webinar, it's a webinar by the International Federation of Engineering Education Societies, and I'm here to represent the Global Engineering Deans Council. Sometimes we tend to talk a bit too utopically, which of course is needed, but we have to make sure whatever we're suggesting has its feet on the ground, it's sustainable, it's achievable. So I'll try to bring all this down to local and individual scales. Right. So all of this reformulated questions were motivated by the vision. This might look familiar to some of you. The vision is the continuation of life on the planet, not human life, life on the planet, making our world more sustainable, secure, healthy, and joyful. And the reason I have the picture of a coral reef here is not only because it's pretty, but also because it's here to remind us that the whole world is interconnected. We can no longer sustain human life or human civilization independently of the rest of the complex networks, systems of interaction of our planet. And it continues from there on, that the nature of technology is one of evolution. And here it's a good reference to remember Brian Arthur, the groundbreaking economist, who's one of the fathers of complexity theory, of course. But he has a book, I believe it was out in 2010, The Nature of Technology, what it is and how it evolves. It's one of the many books that says exactly what we've been trying to say about innovation and the furthering of human civilization, not coming from the individual inventor or the lonesome scientist in their lab somewhere, but building on this immense accumulation of knowledge and technology, and it is teamwork. So we do this in constant interaction with one another and with the past. So instead of what do engineers do, we're posing the question, what must engineers do? And looking at things first, if you would indulge me, from a global point of view, in 2008, the most comprehensive list of things that engineers must do came from the United States National Academy of Engineering. And those were encapsulated in the grand challenges for engineering. When we look at them more closely, for example, making solar energy economical, or advancing personalized learning, or engineering better medicines, we immediately see that none of these are pure engineering problems. While all of them are engineering problems, they're all multidisciplinary. They're multidisciplinary in that no single engineering discipline that we traditionally came to define as mechanical engineering, electrical engineering, civil engineering would be capable of beginning to address the problem. But also engineering as a whole has to interact with economics, with education, with medicine in the three immediate examples I just gave. And all of these problems are plethora of problems, in fact, are as such. They're multidisciplinary, and they tell us that engineers have to work with other disciplines. Having said that, we all have this somewhere in our offices, the UN Sustainable Development Goals announced on January 1st of 2016 look very similar. And I dare say all of these, again, are engineering problems. None of them are pure engineering problems. We'll keep coming back to the Sustainable Development Goals, but the word sustainable should link us immediately back to the vision of sustainable life on the planet, and the urgency about these, urgency about solving these is clear to us. So some of the emerging themes then in our field in the first decade of the millennium have been co-opetition, which keeps us away from the individuals or individual teams, pure competition with one another, doing things in isolation, trying to surpass each other in isolation, but rather making everything better than the next person and ourselves is being part of the cooperation. And this is facilitated by open access. We have to keep evolving technology fast by being in competition with each other, and the competition itself actually facilitates cooperation. So we call this whole system that very much resembles the pretty reef that's in endless interaction with all of its parts. And we call this co-opetition. On the other hand, again, since the 2000s, we've been talking about STEM disciplines, and sometimes this is used sort of interchangeably with technology-related disciplines or even engineering. Now, we all know STEM stands for science, technology, engineering, and well, I know you wanted me to say math, but originally it actually stood for medicine. That's another story for some other time. But the fact is, we're referring to natural sciences here, and also technology and engineering are separated, whereas we all know we're all guilty of it. We use the two interchangeably also. Well, we should not, because engineering is technology plus design. Technology by itself, such as copper to conduct electricity, is there, but the design of the telecommunication network is the job of the engineer. So why is that so important to make that distinction there? Well, design always has human in its center. So engineering is a human-centric discipline, whereas technology need not be. You can be a technology expert, but not an engineer. An engineer has to be a technology expert and then some. Technology provides the tools and materials for engineering, such as the copper or the electromagnetics. My apologies for my examples always come from telecommunications because I'm a wireless comm expert at heart. But then engineering refers to the design of processes and tools, and as far as patentable, licensable, intellectual property goes, method and apparatus. And of course, we have design thinking as an approach to engineering. And it again has teamwork in its center because it's very much human-centric. How is that human-centric? It's always user need-based design, meaning we first empathize, we understand what the need is, and then define, and then ideate. And then we go into the prototyping and testing. And there are infinite feedback loops between these blocks, these 5 stages. It's not a linear progress in design thinking, because there are many people, the stakeholders, the users are involved from the get-go. So it's not an ideation going to customer hoping it will sell kind of linear process. This is understood to be the winning approach to engineering and other fields. Having said all of this, I want to then take a step back and diagnosing the need to bridge the engineering education and engineering field. About 10 years, actually now almost 11 years ago, a group of engineering leaders got together in Paris and signed the declaration, the inaugural statement for the Global Engineering Deans Council. We talked about the US National Academy of Engineering and later on the Sustainable Development Goals. So the backdrop for this was ready, and the need was becoming more and more obvious. The declaration is in some 14 languages, and there was a call to planet-wide action. And there are 4 major goals identified in the Paris Declaration, which is the foundation of the Global Engineering Deans Council. And one of them is to make sure academic engineering leaders share with each other best practices in terms of curricula and research work and so on. Another one is to complete the triage between academe, industry, and wherever possible, government, states, and other public sector. The third one is to enable engineering deans and vice rectors, academic leaders, to contribute to the national and regional socioeconomic development, starting with their university. This is extremely important. And the fourth one, of course, is the quality measures for engineering education accreditation to be at a global standard. So I will not go into detail. This is the Paris Declaration. Out of this, since we're going on to talking about who should the engineer be, I'd like to pull out these words. We need an adaptive engineering leader capable of addressing multiple challenges in an ever-changing world. So I'd like to pull that out and gaze our eyes on those words a little bit, because later on we'll talk about the homo symbios as defined by colleagues at an IFES conference a couple years ago in Seoul. The CEO of POSCO presented this homo symbios, that means this STEM-based collaborative human being who is an engineer at heart, is an expert into her field, but also knows to collaborate with all the other fields. Here is then the who should the engineer be evolution. Look at the hunched over lonesome Homo sapien looking at their computer screen, and then Homo symbios then resembles the adaptive engineering leader as described in the Paris Declaration of the Global Engineering Deans Council. We talk about the T-shaped engineer a lot. The disciplinary expertise, the deepening of the disciplinary expertise is the vertical part of the T. And the interdisciplinary or the multidisciplinary, interactive, communicative part of the engineer is then the horizontal part of the T. And now this vision is extended to the pie-shaped engineer. The last couple of years we've been talking about the adaptive leader who's resilient, who's continuously learning, because we will not be able to fit engineering education as needed by the 21st century or the new millennium, whatever you would like to deploy as your horizon, into a 4 or 5 year education. There is lifelong learning that needs to go on in order for the engineering leader to address the problems we talked about. So I can't let this one go without talking about some of the things that the who should be an engineer folks talk about. To this day, I don't know if I'm right-brained or left-brained, and nor do I care about anybody's brain size, because we know that we have both sides, we all have both sides, and without interaction between the two, we cannot function. So there are no right-brained, no left-brained people. There is no such thing as math brain. There is good math teaching that can be custom tailored to the different styles of learning. We are sometimes focused, we sometimes multitask. We all do this. Strength, endurance, intelligence, perseverance, and physical attributes belong to all of us. These things do not differentiate between gender, race, language, religion, or anything like that. We all have a biorhythm. I'm not an expert, but we can be as logical and emotional as human beings are. And this is my favorite. I've never met Dr. Gray, but greetings to him. I think he has not been, to my knowledge, exposed to the engineering community. Having said all that, I'll come back to the Global Engineering Deans Council Paris Declaration. These are the few good women and men who've signed the original document. So this time, not ironic, but sincere gratitude and greetings to them. As an example, 10 years later, remembering our colleague and good friend, Professor Ramiro Jordan, who could not be with us today, he's been trying to bring this peace engineering into the realm of in the global engineering community. So the 10th anniversary of the Global Engineering Deans Council was celebrated in New Mexico in November last year. And we talked about peace engineering. Sure, it sounds lovely, but it's a lot more than that. What peace engineering is in a nutshell, everything we need to do to meet the challenges posed by the UN Sustainable Development Goals. Only then will we have peace on our planet, and life will be sustainable and healthy and secure and enjoyable. Those are the 4 pillars of the vision. So this is an example of what the engineers must do, and we should feel privileged to be part of this. Now, engineering education community has been waking up to this the last 2 decades. So problem-based learning seems to be a winning strategy. And of course, there's lifelong and life-wide learning, meaning we don't simply learn what do engineers do, but what should engineers do, which is in continuous evolution. That's where the life-wide component comes from. And also, we need to teach engineering profession and identity to our students, which is diverse and inclusive. We cannot continue with the traditional perceptions of who should be an engineer. And of course, we should keep on revisiting how to teach math, physics, and of course, computational thinking to our students. And blended and open learning are again emerging as winning strategies for the digital natives who are our students. And of course, there are many other activities in the engineering education field. We get together all the time to improve on each other's best practices. We get together to improve on each other's best practices through international networks for collaboration in research and development and education. So again, GEDC is one. And I'll give an example of the kinds of things that GEDC does. One of them is to promote diversity, to make sure the perception of the engineering profession is true to what it should be and what it really is, which is diverse and inclusive. So the Airbus GEDC Diversity Award, to my knowledge, is the biggest, most comprehensive, sweeping one in the planet. And that has gotten some traction over the last 6 years. And we're looking forward to many more, making examples out of diversity-inducing methods and projects across the world. Another international network for collaboration in engineering education is CEFI, the European Engineering Education Society. And CEFI is an older body from the 1970s, and it has all these working groups. And we tend to put out position papers in different pressing issues that face the field of engineering. The working groups are physics, math, continuing engineering education, gender and diversity, open and online education. So all of the relevant issues that face us, we have working groups under CEFI that focus on those areas and bring them back, and then we publish position papers, or we tend to distribute some of our findings through a journal, the European Journal for Engineering Education, and the annual conference, the CEFI conference. Having said all that, all of these are made possible by the accompanying student organizations such as BEST or SPEED. Without reaching to the students immediately, I believe these global activities would be just that, global activities at a higher level and not reach the local. So it's really the student involvement in all of these that makes them worthwhile and reaches the masses. So let's look at the current or traditional engineering education curriculum. We have straight lectures, we have problem sets, lab work, projects, graduation projects, internships. So there are some projects and there is some interaction with the industry, but not necessarily a satisfactory one. And there's nothing on professional identity of an engineer, what an engineer, who an engineer should be, and what an engineer should do. So how to go about rectifying this? Well, let's visit what professional identity is. The first thing is, whatever the profession needs as an expertise, the necessary knowledge, and what should be done, the tasks, and so on. The second one is for the individual to feel they belong to this club, for the individual to say, I am a such and such engineer, plumber, fireman. So that's one's individual identity. And the third one is the social component. Without educating all of the profession, we cannot induce a new underrepresented group that feels they belong, but the rest of the traditional thinkers won't accept them. So we need to educate the entire profession to be more inclusive and diverse. So let's take this definition and apply it to engineering identities. Again, the framework of the engineering identity is what the engineers should do, and this is extremely relevant to the students of today's future engineering careers. All students should form an inclusive definition of the profession. The broader perception is going to help them accept underrepresented groups, and then the underrepresented groups will be able to see themselves as engineers a lot more readily, like they ever so well deserve to. The imposter syndrome has been plaguing our female students, our underrepresented groups, and it's simply counterproductive for them to feel that way. So identities are social and need to be affirmed by others. Again, this should be part of engineering curriculum. For the first time last year, I, as a hardcore electrical engineer, taught gender in science and technology. It was probably one of the most satisfying, rewarding experiences of my life. I'll try to do it again this year. Engineering curricula need this. This identity development is a theoretical framework for students' attitudinal changes. In fact, here is a warm remembrance of a colleague who was a professor at Technical University of Munich. Unfortunately, we lost Suzanne last year, almost a year ago. But she was not an engineering professor in the traditional sense. She was an expert of engineering profession development. She's a social scientist. So we need more of Susanna in all of our engineering schools. And of course, through the international collaboration societies, we're able to do wonderful things that reach the local scales in order to motivate and make sure that everyone feels included and everyone is included. Why is this important? Well, other than that, it's a good practice, or it makes sense, or it's the more humanistic approach. Let's go to the more traditional thinking folks and say, if gender equality alone in engineering was solved today, that would generate a $12 trillion industry income into our industry. $12 trillion. I think that's worth it. Now, running low on time, but I would very much like to give a respectful nod to the father of artificial intelligence, Marvin Lee Minsky, who said, can you imagine that there was a time when the books in a library didn't talk to each other? And of course, what he's talking about is to bring down the barriers between disciplines, between the different sections of the library, and making sure all learning and teaching styles are catered to. I'll leave you with an example here. Let's say we want to teach the Fibonacci number series. We could make our students memorize that Leonardo Fibonacci was an Italian mathematician, and he lived in the Republic of Pisa, and he's considered to be this talented mathematician. We can make our students memorize some more things. We could teach this in a history class, or we could include geography and the number systems that we're talking about, and the Fibonacci series, which is used as an example, the Liberabacci, the book of calculation that he published for the first time in the 13th century. If we could get all of this multimedia representation of knowledge together and create the smart environment, smart learning environment for our students, they would remember this forever because they would truly learn. Otherwise, what they memorize for the test tomorrow, they will forget by the evening of the test. So we can give examples of where the Fibonacci series is used, and we can teach it in different ways. For example, doing this and expecting only the quantitative students who are happy with Greek symbols to understand, and the rest will not gain us anything but alienate half our students. On the other hand, some students will learn better if we actually, in words, explain what this number series is, have them construct it by themselves, and teach them what the ratio is. And maybe the computational thinkers will simply plot what's going on. 3 different styles, same number series, same set of applications. It's not the quantitative versus verbal students, it's the different teaching styles that actually matter. So, having talked about all these global approaches, trying to bring them down to a local scale and to the individual, what we're trying to see on the face of our planet for the sustainable, healthy, secure, and joyful life is for the individual to become more of a manufacturer than simply a customer or consumer. So one movement that started again the first decade of this century is the fabrication laboratories, where the access to manufacturing technologies became democratized. And for this to take hold across the planet, open access, open innovation, open design, that is sharing of all that is done in these fabrication laboratories, has enabled populations to quickly get on board. Of course, the open movement in itself we've been witnessing since 1990s, started maybe among academics and artists, lots of nameless traditional art forms were shared first, and then academics started to share their findings, and that led to open data, open science, and so on. And then there is computer scientists and coding that became open, and it all became interactive. So openness is enabling the evolution of technology. And industry collaborations and international collaborations are speeding up the evolution of engineering education, as well as research and development. But the more collaboration with the field, the faster the evolution of engineering education. And of course, gone are the days when students look for jobs at big companies when they graduate, and applicants become supplicants is one of the mottos that I've heard among the more entrepreneurial students. Entrepreneurship is so attractive, and it supports 90+% of the economy. So even the bigger companies are now turning to entrepreneurship as a business model, where their individual departments or divisions will feel like entrepreneurs, except they're cushioned by a bigger company, and so they're a bit more fail-safe than the free entrepreneurs that are out there. And again, the maker movement, the openness of fabrication laboratories, where its trial and error is quick and cheap, so that the trial and error becomes an easier way, a most efficient way to get to prototyping, fast prototyping, makes a huge difference in socioeconomic contribution of certain segments of the society or certain geographies where we did not get those contributions as much before. So we can actually call this a third digital revolution, which is the local or eventually individual manufacturing, as opposed to the mass production of 20th century. In the 21st century, we should be able to see more and more of the individual departing from being a consumer to a producer. And of course, digital design makes this possible, and people want to be makers, producers, fabrication laboratories with the typical inventory of the 3D printer, scanner, CNC, and what else? The handheld smaller machinery makes it possible to access technologies for manufacturing. And this is a grassroots movement that has quickly come around the world. I was privileged to be there when Professor Neil Gershenfeld, the visionary father of FabLabs out of Massachusetts Institute of Technology, came to the National Science Foundation, and we were all excited to be funding some of this amazing new revolution, digital revolution. Here is Professor Neil Gershenfeld in his laboratory called Center for Bits and Atoms, taking things from the virtual world of bits into the physical world of atoms. This is a typical fab lab where you have some of the manufacturing tools and also teamwork areas, because entrepreneurship springs from fab labs and mostly in teams of different disciplines. Here is a basic inventory. So you have these labs networked in Fab Academy, where how to make things, how to use these devices, business models, and so on are discussed. And we also have Fab Research for the more advanced 3D printers, printing organic material and organs, or lining up atoms to come up with smart materials and so on, are researched. So this is all under fabfoundation.org, which is free to join and spans the entire world. And of course, everything is open access. So here are some examples at the local scale. This is a FabLab solar house in Catalonia, and these are the students that have actually made the FabLab in a FabLab, and so the FabLab has made itself. And it's completely sustainable, self-contained in all its energy needs and so on. Another example is the Vox Society, the first $50 leg prosthetic, and also some interior design tools and 3D printed models that they've produced. Another example comes to us from FabLab Afghanistan. Here is a FabLab in a village close to Jalalabad. You'll see women who are not known for contributing to the socioeconomic life in Afghanistan much, that are capable of doing so thanks to the FabLab. Here is Wi-Fi/WiMAX type communications enabler that reaches 50 megabits per second, which is of course badly needed in a mountainous country like Afghanistan. And unfortunately, in a war-stricken area like Afghanistan, we need prosthetics for folks, which are again easier to come up with in fabrication laboratories. The last thing I want to talk about is something that sums up everything we've talked about from the point of view of engineering education. Times Higher Education rankings is something we all care about. It's a reference point for measuring the success of universities, education institutions. Impact ranking is the last ranking system they came up with. I think they got it right. In 2018, towards the end of 2018, they opened their portals for universities to upload their reports on at least 3 of the UN Sustainable Development Goals. They were able to quantify rankings for 11 of them, and the rest are coming up soon. The 17th one, Partnership for the Goals, was a must, and universities had to choose 3 others, and they could choose more of them too, but those were made into quantifiable lists of indicators. And now we have different rankings for every one of the Sustainable Development Goals, so we can see which universities make a difference along those lines. And we have the overall impact ranking system, impact ranking list that they came up with. Of course, it was the first one. Maybe not all universities participated, but we certainly see a departure from the traditional ranking based on numbers of papers and dollars. There are more things that universities do that were not necessarily taken into consideration or maybe emphasized as much in the traditional ranking system. So this is a step in the right direction. With that, we will hopefully continue to work with Times Higher Education also. And I'd like to stop here and thank you so much for your patience.
Thank you, Serene. Wow, what an exciting presentation. All kinds of ideas and themes discussed, challenges, and in particular, I like the thing that you said, engineers must do these things. And we have over 100 people out there who are just thinking, wow, if we must do it, how do we do it? It's hard. Most of us say it's hard. What you're telling us to do is hard, Serene. So let's have some discussion with some of our participants and panelists. I welcome all your participants to just text your questions or comments. In the meantime, I'm going to go through a few people who have put on the panel here to just chat a little bit. Let's start with Françoise. You're talking about the the CEFI. So anything you want to add, Françoise, from your perspective in Europe?
Well, not really. I have to say I would like to thank Shirin because it was quite interesting as well, and a splendid overview of everything that's done in the world, and the link between the new goals for engineering and engineering education. I thought that was quite fascinating. So thank you very much. You were so pleased.
Thank you, Françoise. It's a pleasure to work with you and CEFI too.
Yes, and thank you also because you have presented also what we were doing in this context, and even if you presented on behalf of GEDC, so I was quite sensitive about that, and I think, well, everything you mentioned was quite well reflecting. I mean, the activities we are doing, and maybe I can, as I have a word, maybe I can just take the opportunity to add also to the colleagues who may not know it that soon in September we will have our CEFI annual scientific conference in Budapest that will organize actually on these topics and on the complexity, being the complexity is the new model, and of course all the gender issues and the industry 4.0, and so I hope that perhaps you may have a chance to, if not to attend the conference, but at least to have access to the proceedings, etc., which will be available on our website after the conference. And so far we expect between 350 and 400 participants for you tonight.
Thanks, Françoise. Hans, comment from you?
First of all, many thanks, dear Shirin. It was a very thoughtful presentation. Just a couple of comments.
My pleasure.
We obviously don't have the time, but your whole point, one of the many points, to educate the entire profession to be more diverse is a fundamental issue. And not only in terms of diversity, in terms of gender and so forth, but also the better linkages to the variety of other professions. Again, the interdisciplinarity, again, a very deep and important topic. And I know we will continue to discuss this. You're our incoming chair of the GDC, working closely with Natasha, our current chair, myself. We're delighted at that. Let me just make just a couple of comments. One is to make everybody aware of a very exciting conference in Santiago, Chile in October with the theme Engineering Minds, Hearts and Hands, where Shireen will assume her role as chair. I'm very excited. And those of you who are in leadership positions, we welcome you to that. And finally, something that Shireen and I and about 35, 38 other very fascinating, awesome, inspiring women leaders, we are writing a book on the role of women engineering leaders throughout the world. It's an incredible journey that we hope to finish in a couple of months. And Shireen, I certainly deeply value your engagement, participation in that. That's all, Krishna. Thank you.
Thanks, Hans.
Great pleasure.
While we're having this conversation, I encourage all the participants to really, jump in, because we've talked about some concepts that are really hard to implement. And if you have some thoughts on how you're implementing it in your own organization and so on, it'll be really exciting. Elsie, jump in. Your comments, you sent something in.
Yes, thank you very much. Yes, Shireen, thank you so much. I would like to first share that from a, can you hear me okay?
Yes.
Great.
Okay, from the business community, the evolution of identity that you talk about for engineers is parallel to the evolution of identity for those of us in business. And it is, when we look at how to help business with that, it seems to us it's really a shift in accepting system reality. And once we accept that's the reality, then we start to look at, well, what is my role in it? And of course, hyper interdependent, collaborative, cooperative are some of those attributes. And of course, in changing human behavior, logic and data, we've been told, typically is not enough. We need to look at the emotional component. So I'm excited to hear Hans talk about a conference that is addressing heart. And I'm excited about what that can bring. But a specific question for you is, what we found is telling stories and cases that illustrate to corporate executives and corporate teams a better way, that illustrate what would it look like if I shifted my identity. So engaging that kind of an emotional component with illustrations is something that we found works. Is that something that you can point to when you look at in the engineering education community? Are there cases where this kind of heart shift has occurred that you are studying or can point to?
Beautiful, Elsie, thank you. Other than many initiatives like the book that Hans just mentioned, in other words, just telling stories of women or whoever underrepresented groups in engineering. In my class on gender in science and technology, I started out with primatology because we need to break this prejudice that women, well, they would like to work from 9 to 5. They don't want to deal with physical work or hard work, or, there's all this. So I give them the example of primatology, and I ask them, who's a primatologist that you know? So they'll say Jane Goodall. And so I put up a photo of Jane Goodall. Granted, she's hugging a cute little chimpanzee, but she's in the middle of a jungle, and she's been camping out there. That one photo comes after months and months of being superwoman, literally living the life of a commando in a very dangerous environment. And then the second primatologist that you might have heard of, well, they say Diane Foster. Well, Diane Foster was killed, but she was killed by poachers because she was protecting the gorillas, same kind of lifestyle. And she is hailed as a hero. So that she was killed is not something that deters women from going into primatology. So you can go down the list. I ask my students to come up with the top 10, top 20 primatologists. You start to see one male primatologist maybe within the top 20. Top 10 are women. Why? Because they have these excellent role models. And one of them was murdered, but she was hailed as a hero. They made a high-budget Hollywood film about her life, and her book is a bestseller called Gorillas in the Mist. The Hollywood movie by Sigourney Weaver has the same name. And people, like girls, boys, everybody, want to do something that matters. And when they have the role models in place, when they know it can be done, they'll go to the death, literally. So anyway, that was something that really influenced me.
Okay, thanks, Elsie. Thanks, Sirin. Let me go to Ramakrishna from National Academy of Engineering. Maybe he can tell us how we can all do these things that are so difficult to do, that we must do. Rama, jump in.
Yeah, thanks, Krishna. Thanks, Sirin, for a wonderful presentation. I know the time is short.
Hi, Rama. Thank you.
Yeah, I know I'm going to be communicating with you, and Hans has already introduced us. So I wanted to ask two questions. One is, you mentioned the pie-type shaped engineer. I was wondering if another adjective should be added there, which is adding purpose to it. You got leadership, adaptability, resilience, etc. But I think putting a purpose, engineers to make the world a better place, kind of is implicitly mentioned as one of the motivations and things like that. Maybe that's something that we could think about. And then the other thing I wanted to ask was, we have in universities maybe, I don't know, 10% or something like that would be engineering students, but the remaining 90% are non-engineers. So as engineers, is it incumbent upon us, as engineering educators even, incumbent upon us to educate the non-engineers what exactly engineers should do or must do or are doing, and how it's so important for the rest of the society? So are there efforts that we need to take to really bring the 90% along with the excitement and the creativity and the meaning of engineering?
Want to respond to that, Sirin, quickly, and then we'll start winding up.
Sure. One thing that has been useful in creating an environment at the university where the engineering students are not isolated into their own barracks is to make sure at least the freshman curriculum has gender in science and technology and computational thinking as part of general cultural background of all university students. That has helped engineering students. This is an experience that I firsthand have from my university, but also many others are implementing it. Engineering students then are cushioned in an environment where they're understood better and they can communicate better. So it's not only on the pie-shaped engineers' horizontal shoulders, if you will, to try and communicate with others, but others who understand a bit of the computational logic maybe, and maybe a couple brain or space type general courses will be able to communicate better.
Okay, great. So just a few seconds for a quick commercial here. I know, Sirin, you're coming to Chennai, and so is Hans and a few other people. I just want to make sure that we get the maximum number of people who are participating in this webinar. Think about coming to Chennai. This is the IFES annual conference, and it's being held this year in Chennai from November 13th to November 16th. And somehow I seem to have lost my thing here. Okay, there we go. And so encourage you all. You can still submit papers. The deadline is July 31st. So please come on over and join the discussion, continue these discussions in a nice, beautiful hotel, the ITC Grand Chola, and then maybe even say make a side trip to Taj Mahal or Jaipur. So with that, I would like to end it. Any last words from you, Serene, before we say goodbye?
I just want to thank everybody for their time. And at the very end of the presentation, there's my email. So I look forward to our continued interaction.
Great. And some of the participants have been asking about that's such a wonderful seminar. We need to have a have the recordings, and so obviously yes, we will be sending this out to you. And goodbye, good morning, good evening, good morning, good afternoon, whatever time of the day it is for each one of you. Have a good time, and we'll catch you again for the next webinar, which is in 2 weeks' time. Okay, take care.
And many thanks to you, Krishna, for making this all happen, and a lot of good hard work. Thank you.
Thank you.
Bye.